The artificial intelligence boom is a physical, heavy industry. Training a large language model requires operating thousands of graphics processing units at a feverish pace, converting electricity into heat and computation. Unlike a factory that spins down at night, these hyperscaling data centers draw power 24 hours a day, 7 days a week. The energy demand is continuous and massive. The hardware driving this demand relies on extreme density. Thousands of server racks are packed into single facilities, drawing concentrated loads that existing local grids were never engineered to support. At the exact moment this massive continuous load is scaling up, regional power grids are adding record amounts of intermittent wind and solar. Generation fluctuates wildly, while data center demand remains perfectly flat. This mismatch exposes a severe bottleneck. The physical transmission lines and power plants that make up the national grid are struggling to balance the chaotic output of renewables against the rigid demands of the data economy. Constellation Energy's acquisition of Calpine Corporation attacks this bottleneck directly. By merging the nation's largest nuclear operator with the largest natural gas and geothermal producer, they have assembled a nearly 60-gigawatt portfolio. Achieving zero emissions targets while simultaneously scaling artificial intelligence requires re-architecting how we deploy baseload power and dispatchable generation. The foundation of grid reliability is firm baseload power. This is the minimum amount of electricity that must be generated continuously, without interruption, to keep the grid from collapsing. This diagram models why solar and wind cannot meet this need alone. The flat horizontal line represents the constant draw of a data center. The volatile, jagged line represents renewable generation throughout the day. The red areas highlight periods of absolute deficit. Every time the sun sets or the wind dies down, generation falls below the mandatory demand floor, risking immediate power loss for any facility relying exclusively on that local circuit. To eliminate these deficits without producing carbon, the grid requires high-density generators that run on physical fuels or deep earth heat, nuclear and geothermal power. In California, Calpine operates the Geysers. It is the largest geothermal complex in North America, tapping into naturally occurring steam fields to spin utility-scale turbines. Geothermal energy provides a critical advantage in its capacity factor. It generates firm, zero-emission electricity 24 hours a day, completely insulated from weather conditions above ground. Constellation's nuclear fleet operates on the same principle, but at a continental scale. A single nuclear reactor provides massive megawatt density, acting as the heavy anchor for the entire regional transmission system. Without these high-capacity, continuous physical assets running at all times, the structural math of powering a zero-carbon AI economy fails entirely. Even with a strong baseload, the grid must constantly adapt. Operating a modern power network requires matching supply to demand exactly, down to the millisecond. Grid operators monitor regional networks in real time, watching as clouds cover solar farms or wind speeds drop, instantly removing hundreds of megawatts from the system. To prevent frequency collapse, the grid relies on dispatchable assets. Calpine's modern natural gas fleet can fire up and adjust output on command, acting as a rapid response mechanism to stabilize the network. This interface visualizes the duck curve. Every evening, as peak electricity demand hits, solar production completely drops off the grid, creating an immediate, massive shortfall in supply. To bridge that gap, flexible gas plants and responsive geothermal units ramp up output, perfectly matching the lost volume to keep the local grid from fracturing. These plants provide highly specific ancillary services to the wholesale market. They regulate voltage and frequency, ensuring the electricity flowing into homes and servers maintains a precise, safe oscillation. Large-scale battery storage, like Calpine's Nova Power Bank, is integrated directly alongside these plants, absorbing excess daytime solar and discharging it in bursts to smooth out immediate grid fluctuations. Utilizing natural gas is a strict engineering requirement. It provides the necessary mechanical shock absorption to keep the grid stable while we deploy more intermittent renewables. Constellation has committed to achieving 100% carbon-free electricity generation by 2040. Executing this timeline requires migrating away from fossil-based shock absorbers entirely. The barrier to that transition is first-of-a-kind capital risk. Engineering and building next-generation advanced nuclear reactors requires billions of dollars before a single megawatt is generated. This financial model shows how the Constellation Calpine merger mitigates that risk. It pools the immense predictable revenue of existing natural gas and nuclear plants to create a capital buffer against the high costs of future deployment. The cash flows generated by selling natural gas and nuclear power into wholesale markets are actively transferred to subsidize the research, development, and permitting of new nuclear technology. To maximize that cash flow, Constellation is optimizing legacy infrastructure. At the Crane Clean Energy Center, previously known as 3 Mile Island Unit 1, existing reactors are being restarted to secure lucrative power purchase agreements. They are also executing uprates. By retrofitting current reactors with modernized equipment, Constellation extracts hundreds of additional megawatts from the exact same footprint, avoiding the capital penalty of a new build. Securing license renewals extends the operational lifespans of these highly profitable plants into the 2070s. This provides a multi-decade financial runway. The acquisition of Calpine's gas and geothermal assets acts as the financial engine. Optimizing these legacy operations today generates the capital required to build the zero-carbon grid of tomorrow. The capital generated by the 60-gigawatt portfolio is pointed toward a specific technological endpoint: small modular reactors. These advanced designs rely on a different class of fuel known as high-assay low-enriched uranium, or HALEU. By increasing the concentration of the fissile U-235 isotope, reactors can be scaled down significantly and require less frequent refueling. The precision engineering of this advanced fuel cycle allows modules to be built in factories rather than on site, reducing construction variables and lowering overall costs. Even with a scalable reactor, new power projects face strict logistical limits. Local transmission grids are congested, and securing permits for entirely new industrial sites can delay builds for years. Constellation circumvents these limits by repurposing existing infrastructure. Instead of seeking new land and establishing new grid connections, they deploy advanced reactors directly at the sites of their current nuclear plants. This is already in motion at the 9 Mile Point facility in New York. Constellation is leveraging an established site, a trained workforce, and pre-existing grid transmission lines to pursue early site permits for new reactors. To guarantee the economics of these projects before breaking ground, Constellation signs behind-the-meter power purchase agreements with tech companies, ensuring a guaranteed buyer for the electricity. By directly wiring a small modular reactor to a hyperscaling data center, these facilities operate efficiently off the main grid, protected from regional transmission bottlenecks. Co-locating firm, carbon-free modular power directly alongside heavy compute demand provides the precise, localized scale the data economy requires. The modern grid faces 3 rigid demands. It must be secure, it must be stable, and it must rapidly scale zero-carbon output. Solar and wind solve the carbon problem, but fail on firm stability. Natural gas guarantees stability, but fails the carbon mandate. This map shows how the Constellation Calpine portfolio integrates assets to offset their individual weaknesses. Baseload nuclear and geothermal provide a constant, firm floor. Dispatchable natural gas absorbs spikes in intermittent renewables. And capital from all 3 funds the deployment of localized modular reactors. This 60-gigawatt portfolio establishes the physical hardware and the financial mechanism to harden the grid and supply the massive energy required by the AI era. Thank you for watching our video overview.